All right, now that we've covered proportions and unit rates and their relationship, we're going to take this one step further and move into this thing called slope. And slope is all about a relationship. It's all about a relationship between two values. So let's take a look at this example that suppose my favorite lemonade recipe calls for 8 lemons to 12 cups of sugar, water. Fill in the missing values in the table, being sure to maintain a proportional relationship. What that means is whatever I do to go left to right or right to left, I'm going to continue doing the same thing. So let's take a look at the first one. You'll notice that I have a chart and it says that number of lemons is going to be X and that sugar water cups will end up being Y. And notice that on the graph just to the right, we'll come back to it in a minute, but notice that number of lemons is on the bottom, that's your X. And that cups of sugar water is on the right, which is Y. So we have, in the problem it told you that 8 lemons was to 12 cups of sugar. So we can almost think of that in the ratio of 8, we're dealing with lemons to sugar, water, 8 to 12. So the question I have is for the next one, if I've got 16 lemons, how much would that be? Well, we can go through and we can cross multiply, we can set up a proportion, but the hope that I have for you is that you can see there's a relationship. To get from 8 to 16, we would say 8 times 2. To get from 12 to whatever, we would have to multiply by 2. Therefore, we would end up with the value of 24. Pretty cool. Let's take a look at the next one. Lemon over sugar water. We know we're dealing with 8 to 12 ratio because they gave it to us in the problem. This time we have 6. 6 is sugar water. So we have to figure out what's the relationship. To get from 12 to 6, we would divide by 2. So to get from 8 over here, we would divide by 2, and that 8 divided by 2 gives us 4. Okay, lemon to sugar water using that same ratio, 8 to 12. In the problem, it said maintain a proportional relationship. All that wanted you to do was keep that same ratio of 8 to 12. Okay, that's all it was asking for. So we now are dealing with 2 lemons. So to get from 8 to 2, that would be divide by 4. And so for 12, we would divide by 4. And that's how we end up with 3. So the number of lemons would be 3 and the number of cups of sugar water, the number of lemons would be 2 and the cups of sugar water would be 3. Let's keep going about this using that same ratio of lemons to sugar water. So now we have this 3 halves. Now we know it's 8 to 12 and 3 halves is in the sugar water. So we're going to put 3 halves down here. Okay? Now for this one, we don't know that value. We have to go through the process of cross-multiplying and dividing. Hopefully you know that 3 halves is 1.5. So to figure out that question mark, what we're saying is 8 times 1.5 divided by 12. The reason we would divide by 12, in case you need to see it, is we would get 12 times question mark equals 8 times 1/2. You get 12 times question mark equals 8 times 1/2 is 12. So we then end up with question mark equals 12 divided by 12. And we end up with the answer of 1. So therefore, if I have 1 lemon, I'm using 3 halves. I'm using 1.5 cups of sugar water. For the last one, we have to continue setting up that same ratio of lemon to sugar water, 8 lemons, 12 cups of sugar, because we were given that. And we want to know if there is 1 cup of sugar water. So the way we can think about this is how do we get from 12 to 1? We would divide by 12. So we would do 8 divided by 12. And when we do 8 divided by 12, we get this awful decimal. Now, stay with me for this. If I have 8 over 12, I can simplify by 4 to get 2/3. 2/3 is going to be a lot nicer than dealing with a repeating decimal of 0.6 repeated, especially for where we're going. So notice that I left everything in fractions. We didn't really deal with decimals. And for this part of the unit, you're not going to be dealing with decimals. You're going to be dealing with fractions. And you're going to have to remember to keep things improper, okay? So the first thing we're asked is, what is the unit rate? And we need to have it improper. And what does it mean? So when we take a look at this, we say one of those is going to be the unit rate. And we know it's going to be either the 1 to 3 halves or the 2/3 to 1. The reason we know that's the unit rate is because unit rate has to be 1 for the denominator. So in looking at the ratios, the only ones that would even be applicable would be the bottom two, because those are the only ones with 1. So the unit rate in this case is going to be found by taking our numbers, and we're going to graph them. And that's going to help us answer those questions at the bottom. So let's go through and let's graph what we've got. So we've got over 8 up 12. Hopefully yours looks a little prettier than mine. And we have over 16 up 24. And we have over 4 up 6. And we have over 2 up 3. Now we're not going to worry as much about those bottom two, because those ones are a bit of a pain to deal with. So don't stress too much over those bottom two. Now we're going to draw a line through our graph, hopefully hitting the points. Okay, pretend yours is straight. Hopefully yours was straight. And now we can use this to help us identify the unit rate. The reason we can use this to help us identify the unit rate is because unit rate has to have 1 on the bottom, meaning where 1 is the bottom, where are we? Now, it doesn't line up exactly, right? We can look at that and see it doesn't, but we knew it wasn't because based on the chart, we got these fractions to deal with. So in looking at this, where I circled and then wrote the word unit rate beside it, it said 1 lemon. Well, look at your chart. For 1 lemon, what does that mean? That means if I've got 1 lemon, I have 3 halves, sugar, water, to 1 lemon, right? Now the constant of proportionality says, what do I do to the left to get to the right? Okay, so what do I do to 8 to get to 12? And it's got to be through multiplication only. So we can look at it and say, what do I do to 8 to get to 12? What do I do to 16 to get to 24? What do I do to 4 to get to 6? What do I do to 2 to get to 3? Those aren't very helpful. The one that's going to be helpful in determining the constant of proportionality is seeing that second to last one. What do I do to 1 to get to 3 halves? Well, we would multiply by 3 halves. So the constant of proportionality is 3 halves. Isn't this interesting? Sugar water, 3 halves sugar water, that's cups, sorry, 3 halves cups, sugar water to 1 lemon. So there's that 3 halves idea again. So notice that the unit rate being 3 halves and the constant of proportionality being 3 halves, they're the same thing. Let me give you a hint. It's going to be given another synonym name in a little bit. So now we can take this and we can write an equation. We can say that y equals 3 halves, because all k is that's your constant of proportionality, which we know is 3 halves. So we could say y equals 3 halves x. That means I could take any number of lemons, any number of cups of sugar water, and I could figure out what the other one would be for my recipe. Okay? Hopefully this is making sense. Now, here's the deal about unit rate and slope and constant of proportionality is they're all the same. Okay? It's all about comparing how far over to how far up. Or excuse me, how far up to how far over. So we're first asked to find the rise and run between each sets of points on the graph by counting the vertical and horizontal change, and then we simplify. But we need to leave our answers as improper fractions because if we're comparing two things in a ratio, I can't say that it's 1.5 because that's not comparing a rise over a run. I could say 3 over 2 because that's 3 over 2, but 1.5 doesn't help me, okay? Nor could I say 0.6 repeated. It's not something over something. I could say 2 over 3. The other thing to note is you can't say, like, for 3/2, I couldn't say 1 1/2 because that's not comparing two parts. So regarding slope with this whole unit rate and constant proportionality thing, we want it to be improper because we're only comparing two things. Rise, how far up, to run, how far over. So if we're going between 0, 0, and 2, 3, on your graph, you can go ahead and look to go from 0, 0 to 2, 3. How far up do you go? You count 3 up, and you count 2 over, right? So if I'm at 0, 0, I'm going to go up 3 to get to 2, 3. To get right there, I have to go up 1, 2, 3, and I have to go over 1, 2 to get to my little point, right? So now and that's simplified. Let's take a look at the next one. To get from 0, 0 to 16, 24. Notice that these are all points that are included on the previous page with our lemonade recipe. So to get from 0, 0 to 16, 24, I would go up 24, and I would go over 16, right? Over, to get from 16, 24 says go up 24 and go over 16. I do know I can simplify this. I can simplify it by 8, and I get 3/2. To get from 2, 3 to 16, 24. Well, if I start at 2, 3 and I go up to 16, up and over to 16, 24, I've gone up 21, and I've gone over 14. We can simplify this by 7 and get 3/2. And for the final one, 4, 6 to 8, 12, over 4 up 6, put your point, over 8 up 12, look at that point. We ended up going up 6 and over 4. Rise and run. Rise means how far up, down. Run means how far right, left. We can simplify by 2 and get 3/2. So notice on each of these, when we compared any 2 points, it didn't matter which 2, we ended up with that constant, that unit rate, of 3 to 2. Okay? So slope of the line between any points on the graph is going to be 3/2. Okay? It's going to be 3/2. And it says, where in which ordered pair did you see this in the table? It means if I go back to this table right here, where did I see 3/2? I saw that when I had 1 lemon equals 3/2 cups sugar water. And what's special about this? That represented your unit rate. So your unit rate represents your constant proportionality, but it also represents your slope. So where would you see the slope in this equation? You would see it in the unit rate, or you'd see it in the constant of proportionality. Because they're all the same thing. It's just giving the same word. They're all like synonym phrases. It's giving the same word to the same thing. Okay? So now that we have that under our belt, we're going to calculate slope. Now, slope's always done on a straight line. Okay, so it's always going to be on a straight line. Notice that the line has arrows on either end just because it's going to go on forever and ever. And it says, for each example, shade the slope triangle. The triangle should always be drawn so that you move up and down and then right. So to get from A to B. So the reason they want you to shade the triangle is just to make sure that you are able to see what you're working with. Okay, so there's AB. You don't have to shade it. I like to just because it makes it easier for me. So to get from A to B, notice that you're starting at A. You're going to move up 1, 2 units. And you're going to move 1, 2, 3 units to the right. So therefore our slope is 2/3. I can't write small enough to fit it in the boxes, so I'm just going to write it beside it. Now let's take a look at another example with BC. We go up and over. And there's our triangle. So for BC, we move up 1, 2, 3, 4 units, and we move right 1, 2, 3, 4, 5, 6 units. Again, I can't write small enough. So that's 4/6, but we can simplify that to 2/3. So what relationship do we see between the two slopes? Well, we got the same relationship. It's the same ratio. They're equal. Okay? And again, if it's a straight line, and it should be, you should always get the same relationship. Let's test that theory out on this example. To get from L to M. L, M. There's my triangle. Shaded in. We have to go up 1, 2, 3, 4, 5, 6. And we have to go right 1, 2. So we end up with 6/2, which we can simplify to 3/1. If you want to leave it as 3, that's fine, but I do recommend leaving it as a improper fraction just for the time being till you have a better understanding of this. Now from J to K. We go up 1, 2, 3, and we go over 1. So there's that relationship of 3:1. What do we notice about the two slopes? They are the same. We knew that should happen, but we just proved that it's going to happen. And just to kind of take it a step further, if you go K to L, to get from K to L, what happens? Do I go up 3, 1, 2, 3, and over 1? I do, and it works. If I were to go J to M and do all of that, I would get an equivalent fraction to 3:1. So there's a third example, and I've already kind of given away what you're doing, but let's take a look at it. Now, notice the way the direction of the lines for the first two, how they're starting at the bottom left and they're going up to the top right. Okay, notice that we ended up with similar things. Take a look at this third one. This third one is we're top left moving to bottom right. So because the direction of the lines changed, not everything's going to be exactly the same. Okay? For the first part, we're moving from R to S. All right, let's move R to S. We are, in fact, moving down 1, 2, 3, 4, and we're moving right 1, 2. Now, I moved down. When I moved up and I moved right, that was positive, right? I mean, to move up, it's a positive direction. To move to the right, it's a positive direction when you're looking at the coordinate plane. If you move down, that can't also be positive. So because we moved down, we say that we moved in a negative direction. Think about the coordinate plane. This one, moving up and moving right is positive, but moving down and moving left is negative. So because of that, because you're doing that, it is going to impact the final answer when you simplify things. So we have -4/2, which can be simplified to -2/1, or we can do -2, but it's important that you note that it's negative, and the reason that it's going to be negative is because we're starting top left and going down. So to get from R to S, I had to go down, I didn't go up. If I had gone up, it would have been positive. But because of the fact I went down, that's what made it negative. Now let's get from Q to T. So to get from Q to T, we come down and go over. We're going to overlap a bit, and that's okay. All right, so if you don't want to overlap and you prefer to draw your triangle that way, that's fine. But I'm going to draw it this way. All right, so now to get from Q to T, we go down 1, 2, 3, 4, 5, 6, 7, 8. And we move right 1, 2, 3, 4. So we move down 8, so we now know that that's going to be a negative answer because we went in the down direction. And we moved right 4, which moving right is a positive direction. We can simplify by 4 and we get -2/1. What's the relationship we noted? Hey, we got the same slope for those two, as we should since it's a straight line.